Okay, we're going to continue with chapter 2. We're moving on to page 44 using significant measurements. And in order to see what a significant measurement is, we really have to see what accuracy is and what precision is, because a significant measurement means that it's an accurate measurement. So first we're going to define these, which you've already seen in the video, but basically you see these four dartboard boards. The first one obviously is a good shot. They're precise and they're accurate. Now the next one actually is very precise, but they are precisely wrong, right? They're nowhere near the bullseye. Now the third one right here, that one isn't really precise. They don't go in the same spot, and it's nowhere near the bullseye, so it's not accurate. Over here, this one, it's not very precise, but if you average them all, they're pretty accurate. They're all around the same amount from the bullseye, but personally, I'd rather be that guy. So accuracy is actually the closeness of measurements to the correct or accepted value. The closeness of measurements to the correct or accepted value. So that's basically how correct are you? How correct you are. Okay, that's what accuracy is. Precision, on the other hand, is the closeness of a set of measurements of the same quantity made in the same way. So the closeness of a set of measurements of the same quantity made in the same way. So it's basically how consistent you are. Consistency. So it's how consistent you are with your measurements. You can be consistently wrong. So that's how you can be precise but not accurate. And we have a formula, we use this in lab, for the percent error. It's experimental minus accepted over the accepted times 100. So in lab, this was our lab value. This is our known, or we looked this one up. That's like a textbook value over the one we looked up times 100. And if we're doing problems like this, they have to give you the lab value. They have to give you this one. They don't give you that one, well, you have to go in the lab and find it. So you definitely need to get a lab value when you're doing these kind of problems. Here's a problem. A student measures the mass and volume of substance and calculates its density 1.4 grams per milliliter. The correct or accepted value of the density should be 1.3 grams per milliliter. What's the percent error? So they got 1.40. That's their lab number. They should have got 1.30. That's the accepted or theoretical over the 1.30 times 100. So we take what they got in lab minus what they should have gotten over what they should have gotten times 100, and we get 7.69% error. They're almost 8% wrong. Okay. Now for this next step, I'm going to use this wonderful shade just for a second. We're going to look into something called significant figures, and it kind of shows how accurate your tools are in the lab, how accurate your measurements are. So if we're looking at this, it says measure the following line 3 times, one time using each ruler. Make your answer go to as many decimal places as you can with certainty. Well, look at this first ruler. It's like what you got way back in kindergarten, right? If we're looking at it, I assume this is 0, and this is 4. Obviously, that is 4. I don't have to assume that. But over here, I don't know what that is, so maybe that's the 1. You know, I have no idea. So it's like 2-ish. So if it goes from 1 to 4, I'd say like 2 centimeters. All right, we're going to go a little further. All right, well, I guess it does go from 0 to 4. That's helpful. But it's definitely between the 1 and the 2, so I'm going to do 1.5 centimeters. You could have done a little 1.6 or whatever, I'm not sure. But now look at this. This is extremely accurate. I know this is 0, and I know this is 0.1, 0.2, 0.3, 0.4, 0.5. So it's 1.1, 2, 1, 2, 3, 4, 5, 6. 1.6, and is it right on the line? It's a little over. 1.61 centimeters. So looking at this, you can see how accurate your tool is based on how many decimal places I could go out. So for this first one, I have nothing after the decimal because I couldn't really be that accurate. My ruler wasn't good enough for me. Over here, though, I was able to go to the tenths place. Now, obviously, the tenths place is slightly estimated, right? It's not exact because, as you can see, as we got more and more specific, it wasn't exactly right. But it's an estimated one. It's close to that. Just like this 2 was estimated, okay? As we got more and more precise tools, more and more better measurements, we realized that it wasn't quite right. And then over here, 1.61, this 1 is kind of estimated. So it might not be right on the line. See, the line kind of goes over that dark line, but it's still on the dark line, so maybe it's a little different. If I had a more precise measurement, I could probably go at another decimal place. So as you get better and better tools, you can make more precise or more accurate measurements. And that's where we get into this thing called significant figures. And I know I've talked about it up till now. Significant figures are basically all the numbers that we know with certainty, and the final digit, which is somewhat uncertain or estimated, which is what we just did with those rulers. Now, when we're counting sig figs, we want to know how many significant figures there are, and I will abbreviate that sig figs a lot. If you have a decimal in your number, a decimal point, if it's present, you're going to read it like a sentence, okay? You're going to go from left to right. And I remember this because a decimal, of course, is the same thing you type on for a period. And a period's in a sentence. And sentences you read from left to right. So if you see a dot in there, read it like a sentence, left to right. If the decimal's not present, you go from right to left. We're going to start counting both of these with a non-zero number. So any number that's not 0. And once you start counting, you don't stop. So I'm going to take a look at this first number. It's going to make it a little bit bigger, maybe if I can do this. Just so I can see the numbers, I have a little more space to actually write. I can even go bigger than that. Let's see. Let's zoom it into 300 even. Yeah, there we go. All right, so nice and big, of course. Now, this 1, that's just kind of the number. It's not a decimal there. You know what I mean? I don't want you to think that that's a decimal point. All right, so it's 138.7. There is a decimal, so I read from left to right. I start counting with the first number that's not a 0. So start over here. Well, the 1's not 0, so I have 1, 2, 3, 4. 4 significant figures. Now, the zeros are really the only thing that's ever iffy, because you can round and put a 0 in as a placeholder. So they're the iffy ones. So this next one, no decimal point, so I'm going to go from right to left. I'm going to start on the right. I'm going to start with the first non-zero number. Well, that's a 0, so that's not going to help us. This one will work, though. So I have 1 significant figure in that. For number 3, we have a decimal, so we're going to go left to right. I have to start counting the first one that's not a 0. That's a 0, that's a 0, that's a 0, that's a 0. That's not. 1, 2, 3. Once you start counting, don't stop. That's how you know that last 0 is significant, and there's 3 significant figures there. Next one, again, a decimal point. We're going to go from left to right. Start counting the first number that's not a 0. I only got 1, just the 5. The last one here, 89.0. Go left to right. 1, 2, 3. That 0 is significant. It is important. It's measured because it has that decimal point there. It's exactly 89.0. Now, if we look at number 6, there's no decimal point. I'm just going to do this again so you don't get confused with the decimal versus the numbering system. No decimal, so you go right to left. Start counting the first non-zero. 2 significant figures. If you think you've got it, feel free to pause this and try the rest on your own and then check how I did it. Decimal, so I'm going to go left to right. First non-zero, 1, 2. 2 significant figures. Now these next 2 numbers, 8 and 9, are like the density problems we did a little while ago where it was like 500 and 500 decimal. You said, hey, it's the same number. It's not really, because one has a decimal and one doesn't. So no decimal, I'm going to read this way. I'm going to go with significant figures. Nope, 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 yep. 1 significant figure. The next one, there is a decimal, so go left to right. 1, 2, 3, 4. There are 4. Because yes, 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 yes. Once you start counting, you keep counting. So it's 4 significant figures there. So what the difference is, in number 8, it's an estimated 1,000. So maybe there's like 950 people there. You'd be like, oh my gosh, there's 1,000 people. Whereas number 9, it's like, yep, we checked their tickets, we collected them all. There are exactly 1,000 people. So 9 is an exact number, exactly 1,000, whereas 8 is just a rounded number, around 1,000. All right, for number 10, we're going to go from right to left, start counting with the first non-zero. 1, 2, 3, 4. Oh, I went the wrong way, sorry. There is not a decimal. I read that wrong. No decimal. I'm sure you corrected me. No decimal, so we go 1, 2, 3 significant figures. Okay, those zeros are not significant, they're rounded at the end. The next page, whoa, that's really big. If we look at that table right on the top, is that only 100? Oh, sorry, 125. You don't need to know it. Okay, so you can just cross that right out. You don't need to know this table. It's another way of rounding. We'll get into that in higher levels of math and higher levels of science, but for right now, 150 works. It's not there. So here's practice, rounding the following numbers to 3 significant figures. So I want the 2, the 7, the 3, and the 5. So I get 273.6. Oh wait, that's 4 significant figures. 274 would be my 3 significant figures, sorry. 1, 2, 3, so 274. Now for number 2, I need 3 significant figures, the 1, the 2, and the 5. So I have 1, 2, 6, comma, 0, 0, 0, comma, 0, 0, 0. You want to keep those zeros in there. They are placeholders. They're important. If you just put 126 instead of 126 million, it's very different. Think about money. $126 million is very different than $126. For number 3, I need the first 3. So I'm going to do 346. And for number 4, the first 3 digits, so I'm going to point 0, 0, 5, 8, 6. Okay? So those are all 3 significant figures, and that's how you round them. Now we're actually using significant figures in math, arithmetic. When we add and subtract them, there's different rules than when we multiply and divide them. We add and subtract, your answer is going to contain as many decimal places as the least accurate one. So if we look at the first problem, 2.1 plus 2.11 gives me 4.21 if I type it in the calculator. But the first number, 2.1, only goes out to the 10th place. And the second one goes out to the hundredths. We can only go as far as the smallest one. So my answer is 4.2. My next one, if I add that up in the calculator, I get 26.12. But I have to round that. See, this first one, there's nothing after the decimal. So my answer is 26. For letter C, I add it up in the calculator, I get 471.06. And I'm going to round that to the 10th place because this one only goes to 10th place. So I get 471.1. And then I have a subtraction, so I get 81.232. But I can only go to the hundredths place because that's my least accurate, so I get 81.23. So I'm going as many decimal places as the one with the least number of decimal places. Finally, if I add this up, I get 123.450. But I have to estimate this one goes the least, so I have to go to the 10th place. So I get 123.5 for my answer. So that's adding and subtracting. It goes by decimal places. For the next one, multiplying and dividing, it's going to go by significant figures. It's got as many significant figures as the least significant figures. Okay, so that's why it's in here, obviously. So now we know how to round when we're adding and subtracting. This is how we're going to round our answer when we're multiplying and dividing. This first number here has 4 significant figures. Because as a decimal, we read from left to right. There's 4, plus there's no zeros in there. This next one has a decimal. We go from left to right. Now it's 1, 2, 3. 3 significant figures. So my answer can only have 3 significant figures. So even though the calculator says 0.210, so the calculator says 0.210748. But for significant figures, I had 4 and I had 3, so I can only take the first 3 significant figures. So my answer is 0.211. Now for the next one, let's see how many significant figures we have. We have a decimal point, so we go from left to right. So I have 1, 2, 3, 4, 5 here, and 2 here. So my answer can only have 2 significant figures. If I type it in my calculator, I get 2837.583. Only the first 2 I can keep. So I have 28. Don't drop all those spaces. The numbers you can't use, but we have to keep the spaces so that it's 2,800, not just 28. And the last one here, I have I have no decimal, so I'm going to go from right to left, 3 significant figures. Over here, 3 significant figures. My answer comes out as 890, but technically that only has 2 significant figures. So my answer has to have a decimal at the end. That makes that 0 significant, okay? Because with a decimal, you read from left to right and count. Without a decimal, you read right to left. So that is significant figures. We'll talk about scientific notation in the next one.